Google Trends. What a gift to society this is. If it wasn't for Google Trends, how do we know that the increase in Disney movies in the early 2000s led to an increase in the UK divorce rate? Without it, how do we know about the lesser-known cure for cat scratches that is, of course, Coca-Cola? Am I getting confused by correlation and causation again? When I was at university, I distinctly remember the time that I sequestered myself away in the silent study room. So desperate I was for my ADHD brain to just concentrate for my differential equations exam that I had to remove all other distractions. But as those of us with ADHD know, when the executive function ain't executive functioning, it's so difficult to just get started. So it was on this glorious summer day when I was stuck inside feeling absolutely desperate that I did what any rational person would do in this situation. I opened my laptop and I Googled the word motivation. There, I read a quote that stayed with me for over a decade later. Pain is temporary. Quitting lasts forever. It was inspirational. It was deep. It said something so profound to my 20-year-old self that I still remember it because it helped me get through that day of revision. Now it's been a bit dulled by the fact that Lance Armstrong was allegedly doping at the time, but I can still appreciate the quote for what it was today. My activity that day brought an interesting behavioural question to my mind though, because the people searching the word motivation are unlikely to be the ones that are actually motivated because, you know, they are actually doing the work. No, Googling motivation is the siren song of the demotivated. So being a nerd, I was curious as to whether I could model this. So I went onto Google Trends, happily typed in the word motivation, and then went and got myself a hot chocolate to sit back and look at the numbers rolling in. Now, I don't know if you've used Google Trends before, but if you haven't, then I'm going to take you through it right now because this is fundamental to understanding what we're doing. I'm going to come on here and search for the word motivation, and it's going to default to the UK because if you can't tell by my accent, that's where I'm from. And so we're going to go look at the past day, and we have this lovely graph which shows us how often the people are searching the word motivation in the last 24 hours. I love this because you can really clearly see that most people are searching for the word motivation during the working day. And yes, there are a few kids kind of searching for their homework, and I'm not really sure what 10 PM searches are for, maybe people who don't want to go back to work tomorrow, but you can broadly see that no one's really searching for motivation during the night. It's when they're working that they need some motivation. Now, this is lovely. But while that 8-minute increments of data gives us 180 data points, which is nice to use, most of them are actually 0. And I don't know whether the last 24 hours have been the most demotivating on the planet, or whether our GDP has risen in one day because everyone's been ready and raring to go. So I'm going to increase the window a little bit. The moment we get to a week, you'll realize that the data is actually a lot less granular. Now I only have hourly data, and I still have the same problem. I don't know if this is a highly motivated week or one where people are slacking. I can keep zooming out, 30 days, 90 days. At each point, the data becomes less granular and I have less points to work with. So in order to make this something that I can use, I'm going to need to go big. And when I select 5 years, that's when we're going to encounter the problem that is the motivation for this entire video. Pun not intended, actually. I can't get daily data. And also, why is today not at 100 anymore? Herein lies the problem with Google Trends data. Google doesn't give us data about what is actually being searched because that data literally prints dollars for them. So why would they share that? But what they do give us is the ability to see a time series of how interest in a particular term changes over time by giving us some normalized data. This means that regardless of what time period I use or what search term I use, the peak, the day that has the highest number of searches, is always going to be set to 100. That means if the 1st of April has 50% of the searches of the peak, then that's going to be set to 50. All other points are scaled accordingly. And that's a problem, because I bet when I was lamenting my 5-year data problem, you were thinking, well, just get the maximum window that you can get and just shift that along so that you can get 5 years of data. And yeah, that was my original idea as well. So let's talk about why that doesn't work. So let's look at an example here, just to illustrate the point. I'm going to get the months of May and June, which have 31 and 30 days respectively, which is well within our 90-day tolerance for daily data. So I'm going to look at those months in turn. You can see that the peak for May comes on the 13th of May, and therefore that is set to 100. That's the most searched in that month. Similarly, the peak of June is on the 10th, and that's also set to 100. So does that mean there were the same number of searches on the 13th of May and the 10th of June? If I zoom out now so that we have May and June on the same graph, then you can immediately see that's not the case. On the 10th of June, we get a Google Trends score of 83, which means that the searches on that particular day were 83% of the searches on the 13th of May. But if we weren't able to zoom out, we wouldn't know that. We wouldn't be able to compare which set of data had higher numbers than the other one. Now, not all is lost. We did get a good bit of information from this experiment, because if we load May and June separately, but we also can see with May and June on the same graph that the 10th of June is 83% of the 13th of May, then if we scale the entire June graph down so it's peaks at 83%, then that actually makes it comparable to the data for May. So that's what I decided to do. I'd fetch my Google Trends data in batches, but with a day of overlap. So the first set of data is for the 1st of January to the 31st of March, and the second set of data is from the 31st of March to the 30th of June. Then I have that 31st of March on both graphs, so I can use that to scale the data so that they match. But while this is close to something we can use, there's one more problem that I need to make you aware of first. So when it comes to Google Trends data, Google isn't actually tracking every single search. That would be computationally ridiculous. Instead, it's using sampling techniques to build a representative picture of search activity. This means that while the sample is likely very well built, I mean, it's Google after all, there's likely to be some natural variation. We don't know, for example, if the 31st of March was unusually high or unusually low search volumes within the sample compared to the real world on that particular day. And if we do have some discrepancy, that could introduce an error into our data set. On top of this, we have to consider rounding. Google Trends rounds all its data, so there's no 50.5, it's 50 or 51. Now, this doesn't seem like a big problem, but it's actually more impactful than you'd think. Let's look at why. On the 4th of October 2021, there was a massive spike in searches for Facebook, so much so that that gets scaled to 100, and all of the other searches that are more or less the usual volume are now dropped to around 0. And that error of 0.5 isn't so big when you're talking about comparing it to 100, but when your number is 1 or 2, that's then a huge proportional error. So our methodology needs to be robust enough to handle this noise and variation, not just the scaling. So how do we solve this? Well, we know that on average, the samples are representative. So why don't we just take a wider window? If we take a bigger overlap, then we can minimize the impact of the noise and the rounding effects. So here's the final plan. I know that I can get data for up to 90 days at a time. So what I'm going to do is I'm going to load 90 days in each block, but I'm going to have all of these 90-day blocks to overlap by 1 month. So that I have a 1-month period of overlap that I can use to calibrate my scaling factor. Our overlap goes from just one noisy day to a stable month-long anchor. So it sounds like we've got a plan. I do have some concerns, namely that having all of these batches means that we might get scaling factors compounding errors as time goes, and that could cause some numbers to really blow up in huge spikes. But I won't really get to see how big of a problem that is until I actually go and do it. So here's what I made earlier. So I've written up everything that we've just discussed in code form, and after temporarily getting banned from saving far too much data for Google Trends, I've managed to get actually something usable, and from a first look at this, I immediately thought, oh no, it blew up. The graph on my screen shows a chain together 5 years of Google search data for Facebook. You can see a pretty steady downward trend, but 2 spikes stand out, and one of those is the 4th of October 2021 spike that we mentioned earlier. My first thought was to verify the spikes, so I unironically Googled for information about Facebook on that particular day and found out that Meta had an outage. So I also searched Instagram and WhatsApp, and also found similarly they had a big spike for that day compared to everything else around it. So that implied that the spike was legitimate, there was a higher search volume that day. But was it the right magnitude? When I put my data side by side with Google Trends' own graph, my heart kind of sank. My spike seemed massive in comparison to the Google Trends ones, and I was thinking, how can I handle this? Do I exclude them as outliers? Do I put on some maximum cap on there, or apply some random scaling factor? All of it felt a little bit arbitrary, and I wasn't really sure how to move on from here. That was until I had a bolt of inspiration. Remember, the whole reason we're doing this is because Google Trends data is aggregated to weekly when it comes to large time periods like 5 years. So I have daily data. What happens if I mix my data to be weekly as well? This is where I breathe a huge sigh of relief, because the maximum score on that data point in that 5-year period, that included the 4th of October 2021, was obviously the week containing that day, and that was set to 100. And when I averaged that week, I got 102.8. That is very, very closely comparable. The difference isn't very big at all, and the fact that it starts in about the same place and it ends in about the same place when I average it weekly gives me confidence that I'm on the right track here. I have something that looks and behaves just like the Google Trends data. So now we have a robust methodology from getting a clean, comparable data series for any search term. But it wasn't the search term of Facebook that we were interested in. It was motivation, right? So why am I looking at Facebook? Well, there's one more problem that we need to solve. Now, the reason I was looking at Facebook isn't because I'm in my boomer phase or anything like that. It's because I'm actually interested in something a little bit more ambitious. Not just motivation in the UK, but motivation around the world, so we can understand whether the UK are keen beans or slumming it. This wasn't as easy as I thought it was going to be. Because while Google Trends allows you to compare search terms, it doesn't actually allow you to compare countries. So I could download each data set for each country for motivation, but how do I make them comparable? Turns out Facebook is part of the solution, but this solution is one for the next video, in which we're going to use a basket of goods to compare countries and see exactly how Facebook fits into this. Hit subscribe so you don't miss it when it comes out. So today we started with the question of whether we can model motivation, and in trying to find out, immediately hit a wall, because Google Translator is misleading, not because of a bug or a mistake, but by its very design. We found a way to tackle that now, but in the life of a data scientist, there are always more problems lurking around the corner. Do you have some interesting data science topics that you think we should explore? Leave a comment and let me know. Thank you for watching. I look forward to seeing you in the next one.